So good morning students, welcome back to the sessions on computer communication network. Now we have started with chapter number 2, that is the responsibilities and roles of data link layer. So what we have seen in that is the data link layer is supposed to work for two important functions. One is called as data link control, in which the data link layer will resolve the issue of error control as well as flow control. The next role that data link layer will carry forward is the access control. So two major responsibility lies with data link layer, that is link control and access control, out of which we have already covered how data link layer is covered the error control mechanism. Now with the help of control like CRC, cyclic redundancy check, the Hamming code, so we have seen how an error is detected first, and whatever the error that has been detected, the same frame we can retransmit again. So actually in data link layer, most of the times what we prefer is detect the error and then retransmit whatever the frame has caught with an error. Now let us go ahead, let us take one more step further with understanding of the flow control. Now before we could start with the flow control, we must understand why do we require flow control, what is the need of flow control, and what exactly we do under flow control. So flow control here is needed because whatever the different devices we will be using under any given network, or the devices which are participating in the network, those are configured with a different configuration. Like some of the devices, they will have different value of RAMs. Some of the devices may work with higher frequency, some devices will work with the lower frequency. So the speed with which the devices operate, it may be different, and because of which if certain device which is operating at a higher speed is work as a transmitter, and the device at the destination end is having the less speed, or it is a slow processing device, in that case the transmitter will transmit at a higher rate and the receiver could not match with the speed of the transmitter, and because of which the frame will get lost. So that is the reason why we require flow control, where we will be taking a surety that, or the rather data link layer will take the surety that there won't be any frame lost occur during the communication. So data link layer flow control mechanism is referred to set of procedures or set of protocols used to restrict the amount of data that the sender can send before waiting for the acknowledgement. Okay, sorry for the interrupt. Now flow control here refers to the set of procedure or the set of protocols used to restrict the amount of data that sender can send before waiting for the acknowledgement. So what we are doing here in flow control is that whatever the data that we'll be transmitting, whatever the frames that we will be transmitting, those frames will be given a certain sequence number, so that we can identify each frame from the other available frames that we are transmitting, so that if at all any kind of error occur, if at all any kind of problem occur during the transmission of the frame, same frame can be resent. So that is what the main agenda behind how we work on the flow control. Flow control also check that whatever the frame that we will be sending to the destination side, destination will acknowledge that particular frame once it receive it. So here we will be getting confirmation that whatever the frame that we have sent, whether it has reached to the destination or not. So with the help of error control mechanism and with the help of acknowledgement frame, we can definitely control the flow of data whatever we will be transmitting from the source end to the destination end. So that is what the main agenda behind, or the main working principle behind the flow control, that what it is going to do is it is going to sent a frame, it is going to sequence that particular frame. It is going to give certain numbering to that particular frame, and then once that frame is received at the destination end, destination will reply to that frame with an acknowledgement. So this is how the process is going to take place. Now as far as different level of protocols available at the data link layer associated with the flow control, total 5 different set of protocols are available, out of which 2 categories are made here. One is for the noiseless channel and another is for the noisy channel. Now here generally most of the times what channel that we came across are only the noisy channels. We hardly get any noiseless channel. So this is just for the basic understanding that how these basic protocols work. To understand those, we will go ahead with learning these 2 protocols, that is simplest protocol and stop and wait protocol. Other than that, most of the times we will be requiring, or practically what protocols that we will be using, those are stop and wait protocol, go back NARQ, and selective repeat ARQ. So stop and wait ARQ, go back NARQ, and selective repeat ARQ. So these are the protocols that we will be using practically. Now here let us start with the first category, that is noiseless channel. Firstly, again, it is just an hypothesis. There is no channel which is free of noise. So this is just for the basic understanding what kind of simplest how the protocols are into the working. So first protocol here for the noiseless channel is the simplest protocol. Now as the name indicate, what exactly the simplest protocol is? So simplest protocol is just transmit the data, don't bother whether the receiver has received it or not. So what simply the design of this protocol work here is, this is a sender side. So sender side will get data from the upper layer, that is network layer. Then that data will be processed at data link layer. Now here process means the data will be converted into frames, and those frames will be transmitted to the physical layer. Then these frames will be called as a data frames, and these data frames will travel over a transmission channel. The receiver side at physical layer will receive these frames, then it will forward it to the data link layer, and data link layer then forward it to the network layer. So in short, there is no mechanism to check whether whatever frame that has received is received correctly, whether it has any kind of error, whether some of the frames which are sent by the sender will get lost at the receiver. So there is no such concept of checking or synchronization between the sender and receiver. So sender and receiver both work independently. There is no mechanism which will check that whatever happening at the receiving end must be communicated to sender, or whatever happening at the sender end must be communicated to receiver end. So there is no such mechanism. If we go for what kind of different events occur here, so there is only one event occur, that is the event number 1. There will be a request from the network layer, and once the request is received, the data link layer will start into the operation. That the data link layer will convert whatever data received from the network layer and convert it into number of frames, and those frames will be immediately transmitted. Then what will be the task done, or algorithm done, or event occur at the receiving end is, there will be a notification from a physical layer to the network layer at the receiving end, and then it will start receiving the data only. That's it. So only 2 notifications that it will get from sender side. There will be a notification from network layer, that is upper layer, and from receiver side there will be a notification from the physical layer to the data link layer. So these protocol only work on the notifications what it receives from the upper as well as lower layer. So there is no error control, no flow control. This is the simplest form of the transmitting of the data, so which is not of use because this is not going to help us to detect the error as well as control the flow. Then next protocol, or even if you want, we can go for the what kind of program that will run here. So here also, just for the basic understanding, we can look here that it will wait for the event loop will be executed, where the receiving side will sleep, the transmitting side will sleep until the event occur. So no action will be taken until event occur. Now here event, that means the request from the sender side, that is a notification from the network layer that the data need to be transmitted. Now if that is there, if that request is available, then the data will be taken in a command, call it as a get data. Then it will start making the frames, and once the frame is made, it will start transmitting the frame. So these are the only event that took place at the sender side. And if we look for the receiver side, there is again one only event, that it will wait for an event if event is arrival notification. Here arrival notification, that means the notification given by the physical layer to the data link layer. So once it is there, then frame will be received, then the data will be extracted out, data will be taken out, and the data will be delivered to the network layer, which is the layer above the data link layer. So simple work for the transmitter and simple work for the receiver, that take the data, make the frame, transmit it, get the data, extract the data, accept the frame, extract the data, and pass it on to the network layer. This is how the simplest protocol work, without error detection, without flow control. So if at all any problem occur, this protocol is not going to give us any kind of solution. Now let us see what could be the flow, how the flow will take place for the every individual frame. So here we can see this A here indicates the sender, B here is the receiver. So once the request is available here, from the request the frame will be transmitted, frame will be reached to the receiver end, but there is no acknowledgement. Immediately whenever next request is there for the sender, the frame will be sent. So in between this patch there is no request, so no frame is sent. Here the request is again there, so this frame will be transmitted, and receiver has only one role to play, that is it will wait for the frame to arrive. Once the frame is arrived, the data will be transmitted to the upper layer, or notification will be given from the physical layer to the network layer, and the data extraction process will take place. Now as simple as this, the simplest protocol is not going to help you for error control as well as for the flow control. Now let us go ahead, move ahead with the what additional feature that can introduce here in next type of protocol, that is called as stop and wait protocol. Now as the name here indicate, the stop and wait protocol here is the first protocol which is suggested that once the receiver receives the frame, it must send an acknowledgement. So this kind of protocol will make sure that, now here you can see in the diagram as well, the sender will obviously, just like the previous protocol, simplest protocol, sender will wait for the network layer to send a notification related to transmit the data. The data link layer, what it is going to do is going to format or form the number of frames received, number of frames from the data which it received from the network layer. Then it will be sent to the physical layer, where the data frame will be transmitted on the physical link or transmission link. Then once the data is received at the receiver, it will receive the frame. At data link layer, the frame will be extracted, data will be extracted, header will be removed, and that only data will be captured, and then that data will be given to the network layer. Now once the data is extracted, immediately the data link layer will send a frame. Now that frame is called as an acknowledgement frame. Sorry for the interrupt again. Now this stop and wait protocol, as we discussed here, the only difference between simplest and when the receiver receives a frame, it will send an acknowledgement frame like this. Now once this acknowledgement frame is received by the sender, then and then the sender will start transmitting the next frame. So it is just like, now if you go for number of events occur at the sender end, you will find that sender need to have two kinds of events. Event number one, it must receive a request from the network layer, that is layer above the data link layer. That data has to be sent, and at the same time it must also receive a notification from the physical layer at the sender end only, which will tell that whatever earlier have sent, it has been received by the receiver. Until unless earlier frame is received and the next frame is to be transmitted as per the request from the network layer, the frame will not be formed and will not be transmitted by the data link layer. It is as simple as that data link layer, the transmitting end data link layer will follow an AND function, which want the two condition must occur, then and then the transmission could be started. Condition number one, that there should be request for transmission. Condition number two, that whatever earlier frame is transmitted, it should have the acknowledgement for that frame. That means if the communication is already established and the proper acknowledgement is also receiving, then and then the next frame will be transmitted. But if you observe here closely, there is no change that has occurred in the receiver side for the data link layer. That receiver side, the number of events that occur are same. That it will just wait for the notification from the physical layer. It will wait until the frame is received, and once the frame is received, it will accept that particular frame, extract the data, and then hand over the data to the network layer. So this is how a stop and wait protocol works. Now this is how the algorithm for stop and wait protocol. Only change that has happened here is it will wait for the event, obviously it will wait for the request, and here you can see the change, that is AND. So it will not only wait for the request to send, it will also wait for can send. Now can send here is nothing but the acknowledgement for the previous frame. Now this is what the algorithm for the receiver side, which is exactly same as that of the simplest protocol. Nothing has changed here. Only thing is that it will wait for the arrival notification, that is data from the physical layer. It will receive the frame, extract the data, deliver the data, and additionally what it has is send frame. So send frame here is nothing but the acknowledge signal will be, or acknowledgement signal will be sent to the transmitting end. So this is what the stop and wait protocol is. Now if you look for the delivery detail or the flow diagram for stop and wait, here you will see that the sender A, this blue line frame indicate that the data has been transmitted in the form of frame from A to B, and this saffron line indicate that whatever frame that has been sent here is acknowledgement or is by this particular frame. And once that acknowledgement is received, this arrivals information will be given to the sender end, then and then next signal or next frame will be transmitted. So in short, this transmission will be carried out here like there should be a request from the network layer for data transmission, and there should also acknowledgement signal from the receiving end, and then this transmission would took place. Now what could be the possible problem with this kind of protocol? Now problem with this protocol is, if at all assume that this particular frame which has been transmitted is get lost into the network, if this frame is not received by the receiver, what will happen? The receiver will wait for the event to occur. Receiver will wait that, let us wait for the arrival notification, and until unless arrival notification occurs, the acknowledgement frame will not be sent from receiver end to the sender end. Now how the protocol is designed for the sender end is, it is ANDing operation of both. That is, it should have request from network layer and it should also have the acknowledgement signal, out of which if acknowledgement signal is not there available from the receiving end, obviously ANDing operation output will be 0, and when ANDing operation output is 0, the frame will not be transmitted. So in short, if one frame during the transmission fails, or one acknowledgement during the transmission fails, the entire communication would stop, because the transmitter is definitely wait for the acknowledgement and the request from the network layer, without which it will not take part into the transmission. So this is how the stop and wait protocol work. This is what the problem associated with the stop and wait protocol. So let us go ahead with understanding with the next protocol, that is stop and wait, and in addition to that one additional signal is sent, that is ARQ.